Writing equation of a line perpendicular to a given line. In the last video, I went through writing the equation of a line parallel to a given line. Now I want to write the equation of a line perpendicular. So for sake of argument, I have got this line. So y equals 3x minus 4. And I want a line which is perpendicular to this line. As you can see, going to be many perpendicular lines. In order to fix it, I need to tell you, for sake of argument, it passes through a point 2, 5. So that would fix that line. So perpendicular and passes through a certain point will be only a unique line. It's not going to be series of lines perpendicular. As you can see, my pen is, as I move it, is perpendicular to the given line. But once it goes through a certain point, it'll be fixed. In the last episode, I told you that when two lines are parallel, they have the same gradient. In perpendicular lines, the gradients multiply and must equal to -1. So condition for two lines being perpendicular is m1 times m2 equals -1. If you make m1 the subject, m1 would be -1 over m2. Or if you make m2 the subject, would be -1 over m1. So that means the gradients are negative reciprocal of each other. Now you see with this example, this line has a gradient of 3. M of this line is 3. M of perpendicular to this must be negative reciprocal of this number. That means plus becomes minus, and 3 as a fraction can be written as 3 over 1, and we invert this, negative reciprocal. So that would be the M of perpendicular to this line. Now I've got a situation that I have to write the equation of a line with a given gradient and going through a certain point, which is, we know already how to do it. Equation of this line would be y equals mx plus c. M is 1/3 minus 1/3. And in order to find c, I'm using the fact that it passes 0.25. Since point with the coordinates 2, 5 belong to the line, its x and y coordinates must satisfy the equation of the line. So I'm replacing the x with 2 and y with 5 in the equation of the line. So y comes 5 minus 1/3 of x plus c. This equation enables me to find the value of c. So that's minus 2/3, deducting minus 2/3 from both, adding 2/3 from both sides to get rid of minus 2/3, or moving minus 2/3 to other side, change sign, change side, we have this. Therefore c is 5 and 2/3, which you're going to replace now in the equation. So we have both m and c evaluated. this line is perpendicular to the given line and has passed through point 2, 5. I'll give you another example. Another example on writing perpendicular line to a given line. Here, I'll make life a bit more difficult. All right, we have an equation 3x plus 4y minus 1 equals 0. And I want to write the equation of a line which is at 90 degrees to this line, and I must specify what point is going through. Say this point, minus 3, minus 4. Now, the issue at the moment is what is the m of the given line, because I have not written this in the form of y equals mx plus c. So that would be my first action here. Make y the subject. So we have 3x plus 4y minus 1 equals 0. I'm moving 3x and minus 1 to other side. Change side, change sign, or balancing both sides by writing minus 3x plus 1 on both sides. Change side, change sign is just a quick way of doing what we do by balancing equation. 3x moves to the other side becomes minus 3x, and minus 1 moves to the other side becomes plus 1. I still haven't got the value m because y is not on its own. So in order to make y the subject, I'm going to divide everything by 4. Every term by 4. This way, you're not upsetting the equation. The equation remains balanced. So 4 and 4 cancel. So y equals minus 3x over 4 plus a quarter. Now I know the m of this line. The m of this line is the coefficient of x when y is the subject. This is the m of the given line. So the m of perpendicular to this, m of this line, would be the negative reciprocal of that. Already minus. So minus becomes plus. And reciprocal of 3/4 is 4 over 3. So I now have this information to write the equation of the perpendicular line. Starting with the general equation of the line, y equals mx plus c. We now obtained m, which is 4/3 of x plus c. And in order to find the c, which is called the y-intercept, I'm going to use the fact that it passes point minus 3, minus 4. X coordinates, y coordinates. If the line passes through a point, the x and y coordinates of the point must satisfy the x and y of the equation of the line. Therefore, minus 4 equals 4/3 of x plus c. 3 and 3 would cancel, so we have minus 4. C in this case would be 0. Now replacing this into the equation with this only c unknown, y equals 4/3 of x plus 0, or just y equals 4/3 of x. This line is perpendicular to this line and will go through this point. So the equation of this line is y equals 4/3 of x, and c came to be 0. Writing now equation of perpendicular bisector of a line joining two given points. Now, I'm going to give you 2 points, and I want you to obtain the equation of the line which cuts the line exactly in half, and it's at 90 degrees. So this is why we say perpendicular means at 90 degrees, and bisect means cuts in two equal parts. So let me give you a point here with coordinate 3, -5, and say B is -2, 8. I want a line which goes through the middle of AB and is perpendicular to AB. So it's called perpendicular bisector. We need the M of this line. And M of this line depends on the M of line AB. Whatever line of AB's gradient is, the gradient of the line perpendicular would be negative reciprocal. Previously, we talked about how to find the gradient of a line joining 2 points. M of AB would be change in y divided by change in x. So M of AB, change in y. Start with one of the points, say B, 8 minus -5. 8, change means take away. The second coordinate is -5. Need to go back again to point B, that's -2, -3. So we have 13 over -5. In this case, the M of this line would be negative reciprocal of that, so be plus 5 over 13. So we found the gradient. The question is, I need to know a point that the line goes through, and that would be this point here. That is the midpoint of line AB, the line joining A to B. For the midpoint, I'll call it M for midpoint, we need to calculate both the x and y coordinates of this point. To find the midpoint, you add the x coordinates together, so 3 and -2 divided by 2, and then add the y coordinates divided by 2. So if I write it again as a single number, 3 take over 2, 1 divided by 2 is half. -5 at 8 divided by 2 is 3 over 2. So I know what point is going through and what gradient. So that would be just as a previous examples. Y equals mx plus c. Y equals 5 over 13 x plus c, which passes the point half 3 over 2. Let's replace, this is the x value, that's the y value. So 3 over 2, 5 over 13, x is half, plus c. We need to work out multiplication of these two fractions and then subtraction of these two. 3 over 2, that is 5 over 26 plus c. Moving this to the other side. The numbers aren't very friendly, but never mind. Finding the common denominator. Divide and times. Divide and times. 26 divided by 2, 13, times 3, 39. 26 divided by 26, 1, times 5 is 5. Therefore, 34 over 26, which can be simplified to 17 over 13, will be the value of c. Now, we can write equation of the line. Y equals 5 over 13x plus 17 over 13. And if you want to multiply every term by 13, you have 13y equals 5x plus 17. That is the equation of perpendicular bisector of the line AB. So in this video, I went through how to write equation of a line perpendicular to a given line, and also the equation of the line which halves a given line and is perpendicular to it, which is called perpendicular bisector. Next lesson, I'm going to show you how to divide any line in a given ratio. I hope you've enjoyed your lesson today. Till next lesson, bye.